Hey folks, so we're looking at section 4.1 and I have two new parents to introduce to you. One of them, as you can see, is called the reciprocal function and the other one is called the reciprocal square function. Remember that for parents there are three things that you have to memorize. First of all, you have to memorize the equation. So for the reciprocal the reciprocal function, the equation is f of x is equal to 1 divided by x. The second thing that you have to memorize is going to be the name of the function. So that's simply going to be the reciprocal function. And then thirdly, you have to memorize the picture of the graph. So that's what I'd like to get first, is the picture of the graph. Before I move into this, remember that anytime you have a fraction, there's always a number in fractions that you're never ever allowed to have, and that is a 0 on bottom. You remember that we've talked about this multiple times this semester. When x is 0, and that causes the denominator to be the denominator is 0, then what we have is that our fraction is undefined. And what does that mean on the graph? Well, we're going to actually have a dashed line. This is all the places where x equals 0. That's going to be on the y-axis because I'm not allowed to have an x value of 0 when it causes the bottom to be 0. Now, no matter how hard you try, you're never going to be able to make your y value equal to 0 either. So we're going to have a dashed line on the x-axis, which is y equals 0. These two dashes are called asymptotes. Now this has a funny spelling, as you can see over here on the page, asymptote. And basically an asymptote is a place in my graph that I can never reach. No matter how hard I try, I can never actually get there, but my graph is always going to get closer and closer and closer and closer to that asymptote. It'll never reach it though. So remember with our other parent graphs, we always had special points to remember. So let's plug in a couple things. Of course, I cannot plug a 0 in for x. We've already discussed that. But I can plug a 1 in for x. If I plug in 1, 1 divided by 1 is 1. So I'm going to have, if I call this 1 and this 1, I have the coordinate 1, 1. I'm not going to take the time to get the rest of the coordinates, but you could plug in a 2. If I plug in a 2, 1 divided by 2 is 1/2. 1 divided by 3 is 1/3 and 1/4 and 1/5 and 1/6. And you can kind of tell that I'm going to get closer and closer and closer and closer to that asymptote. I'm never actually going to reach it though. On the other side of this coordinate that I've drawn here, you also have things like a half. If I plugged in a 1/2, I would end up having, if x is 1/2, y is 2. And if x is 1/3, y is 3, and so on and so forth. And so on this side, things are getting higher and higher and higher. Again, I'm getting closer and closer and closer to that asymptote, but I'm never actually able to reach it. Now that takes care of the positive side, but what if my x's are negative? So if, going back to my original equation, if x is -1, 1 divided by -1 is -1. So I have the coordinate -1, -1. Same thing, if my x value is -2, then I'll be looking at 1 divided by -2, or -1/2. Or -1/3, -1/4, -1/5, etc. So you can tell that here I'm also getting closer and closer and closer to that x-axis, never actually reaching it. And over on the right side of that coordinate there, if I were to plug in a -1/2, I would be graphing down at -2. Or if I plugged in a -1/3 and divided those two fractions, I would end up with a -3. Now, you already have this graph drawn on your notes if you've printed your notes. Let's take a look at the domain and range. Domain left to right. So as I move from the left, I'm starting at -infinity, but I have to take a break at the asymptote, so I'm only going to get to go to 0. I can't actually step on the asymptote, so I'm using a round parentheses. I'm going to hop over the asymptote, pick up again at the x value of 0, and go all the way to positive infinity. My range begins at the bottom. So at the bottom, I have, again, -infinity up to 0. I have to hop over that horizontal asymptote, and we're going to go from 0 to positive infinity. Increasing, decreasing, and constant. These are things that we're accustomed to. So my graph, as I start on the left, I notice that my graph is going downhill. It's going downhill. So this is decreasing. It's decreasing from -infinity to 0. And as I go to the next piece of my graph, as I move left to right, it's still going downhill. So I'm still decreasing from 0 to positive infinity. There is no increasing on this graph, and there's no constant on this graph. My vertical asymptote, you know what vertical means. My vertical asymptote is the line at x equals 0. Remember, all vertical lines have x equals a number as their equation. My horizontal asymptote is at y equals 0. This is for the parent. And of course, all of the things that we just listed here, you can be able to tell this if you know what the equation looks like, if you know what the graph looks like. Now let's go to the reciprocal square function. This is very similar. Once again, I cannot have a 0 on bottom. So this gives me a vertical asymptote at x equals 0. We'll go ahead and write that down. Since I can never make my y equal 0, I have a horizontal asymptote on the x-axis, also known as y equals 0. All horizontal lines have y equals a number. If I plug in important points, of course I cannot plug in 0, but I can plug in 1. So 1 divided by 1 squared, well, we know 1 squared is 1, so 1 divided by 1 is still 1, 1. And quite frankly, in that first quadrant, my graph looks exactly the same for the reciprocal square parent as it did for the reciprocal parent. Here's the difference. If you plug in -1, a -1 times a -1, or a -1 quantity squared, is positive. So 1 divided by +1 is +1. And what you'll find is that my reciprocal square parent is symmetric about the y-axis. You've learned that phrase before. So as I'm looking at my domain from left to right, we have from -infinity to 0, hop over the 0, pick up again 0 to infinity. My range, however, is different. There's nothing at the bottom of the graph. My graph doesn't begin until I hit 0, and from 0 to infinity. Increasing, decreasing, and constant. So as I move left to right, the first piece of my graph is going uphill. So this is increasing. It's increasing from -infinity up to 0. But then when you look at the second half of your graph, left to right, it's going downhill. So you have to turn around and go decreasing from 0 to infinity. Those are your two new parents for Chapter 4.